for you today. So we just went through our dissolved oxygen and kind of showed some of the myths there with different volumes, and that really we believe that it's the longer time that air is exposed to the water, the longer time you have it in suspension. Micro bubbles, what we really like to do, I might show a video of it in one of my fish tanks later, is to put a circulation pump right above an air stone, and it chops up all those bubbles, makes them into really small bubbles that just keep circulating and circulating and circulating without ever making it to the surface to pop. And that, I think I should have a pretty good imagery of it for you, if I can get that video with my fish tank. However, right now I'm going to be doing a few titrations. So right now we have these guys on the left are going to be from a nutrient solution that's been aerated. I'll go more into why that's happening later. I know that's not really super conventional, but that is just kind of a control for the compost tea trials that I'm doing. And on this side is going to be a vermicompost tea that has been brewing. They've been brewing the same time under aeration, exact same amount of time. This one was following the dosage volumes per gallon basically in a reservoir. And this one is 1 pound of compost in a bag. In a media bag for a fish tank mainly, but that is what it's suspended in. Both of these are being brewed in a 5-gallon bucket. As if you watched the previous video of the dissolved oxygen, you just saw those buckets. The ones in the back that I didn't really give too much camera time on are the compost ones. But anyway, so we're going to go through a couple titrations really quick. These are all pretty simple. I really like API. They make very easy test kits. And as I was mentioning in one of my first videos, I think it's very important that people learn to become mindful whenever they're taking data. Just because you really hate to waste time, redo something that you've already done. It's not a whole lot of fun, especially whenever you have a whole lot of data sets to do. If you're doing 90 or 300, it can really be a pain if you have to redo a test. So what I'm doing here is, this is a nitrite test. I'm going to start off with ammonia and nitrite because in my opinion those two are kind of the less interesting ones, at least for the brews that we have going. But I did just want to show you kind of every test that I do on these trials. And so I'm just going to be showing it to you back to back. So the first one is nitrite, and it's a 5-drop per test. It only has 1 solution. I'm now doing ammonia, which has 2 solutions, and they are each 8 drops. And if you notice me getting quiet, that is usually because I'm counting in my head. I might try and count out loud for you guys. And normally you're going to want to read the instructions for each of these titrations. I've been doing them for a while now, so I'm fairly familiar with it. And it's something that I've been doing at home for personal and here at the school for research. And I'll do my best to try and keep them in the order that we're doing them in. So the ammonia is actually a 2 solution. I always get the bottles in good shape just because you never know if it's settled or if it needs to be mixed up. Most of these are pretty thick solutions, so they really benefit from a good clear shape. At least right before being added. Kind of helps you keep from skewing the results. And I just wanted to show you these because it's a really good delineator for organic versus inorganic. You really can see through these titrations the dynamic processes that are going on in a compost tea and the ones that are not going on in a nutrient solution. Even if it may be kind of an organic nutrient solution, you will get it. Just usually not to the same degree that you would with a compost. Now we will move on to the nitrate. This is actually one of my favorites. This is a very common test. Most of the time you're looking for nitrogen, and the most common nitrogen you're looking for is going to be those nitrates. That is your plant available form. And guys, I am just rattling off stuff that I have researched, through different papers. I am very much still, a beginner at this. They always say that you are building to become an expert with your masters, so that's what I hope to be, but I don't really consider myself fully an expert yet. So if anything I say is wrong, or you think maybe is incorrect, please feel free to correct me. Leave a comment below. I love to share information, and that excitement sometimes gets a little too zealous, and I share misinformation. And misinformation is one of the worst things in this universe to me, just because we've already got enough confusion, and right now all we need is the truth. So if anything I say is wrong, please feel free to give a shout out, and me and the community can look it up and we can figure out what exactly is the right answer, because that's really all we're looking for here. As you can see, we're already getting some color differences between these. So you can tell that there's obviously a chemical difference between the compost teas and the regular nutrient brews, or some people call them synthetic nutrient brews, salt nutrients. There's a couple different words depending on exactly how you apply them and where you source them from. And guys, if you have any questions about any of the processes I'm doing, if you have any research ideas that you would like me to examine, please feel free to leave a comment with that, or just discuss it in general. I'm always looking for new ideas. We have several students here who are always looking for new ideas, and so the more ideas we have, the more we can research, the more we can test, and most of these students are hourly, and so they're trying to get paid and are looking for projects to do. Likewise, if you would, we don't have a whole lot of testing capable to us, but if you do have some light inquiries to soil or anything like that, feel free to let us know, and we can try to do some testing for you. And like I was saying, titrations, both of these kits costed about 30 bucks. Not too much. And if something happens to them, then you're only out about 30 bucks and you're not out $1,000 probe. Alright guys, so in order of tests we did, we started with nitrite, and then we went to ammonia, and then we went to nitrate, and then we went to phosphate. Nitrate and phosphate are the two plant available forms. And those are your nitrogen and your phosphorus amounts, which are the two most important, in my opinion, and many other people's opinions, the two most important nutrients. Potassium is also important in there, but that's your general hardness, kind of. And nitrogen and phosphorus are going to mainly lead to a lot of your dry growth, or your green growth, and any algal blooms or explosions that you have, especially phosphorus. So here we go guys, I'm going to try and get you a white sheet behind them so you can really kind of see the color differences between them. And so what I'll do is take the first ones together. This was the nitrite. As you can tell, the first one is basically at about 0 parts per million on nitrite. The other one is somewhere around 2 to 5 parts per million nitrite. And that is going to be the difference. So in the compost tea, all of the nitrite has been converted into nitrate because of the nitrifying bacteria in it. In the nutrient solution, it has not been converted. This was holy mackerel, so some of it is nitrite and some of it is ammonia, some of it is nitrate. But as you can see, we have a stop in the process here. Something is not continuing that nitrite into nitrate, whereas it is in the compost tea, it isn't in the nutrient fertilizer. And so that's something that will be brought up as we go through this. The next one that we did was ammonia. So as you can see here, again, the nutrient solution has very, very high ammonia, as it had very high nitrate, whereas the compost tea has almost no ammonia, and it almost had no nitrate, which means both of those precursors to nitrate, your final plant available form, have been completely converted out. And after that we went on to nitrate, the plant available form. This one's a little bit harder to tell the color differences, so I'll go ahead and put that card back behind so you can see that there is a slight difference. And over here we're getting about, I would say about 5 parts per million of nitrate in the organic fertilizer, or in the nutrient fertilizer. So it hasn't been converted from the ammonia to the nitrate all the way there yet. Whereas in the compost tea, we're sitting at about 40 parts per million. And that's because the ammonia has been converted into nitrite, and that nitrite has been converted into nitrate, the final plant available form. And if we had some plants in here, they would be uptaking those. And finally, we will go on to one of my favorite chemicals, and the one that is being mined at the fastest rate currently, phosphate. I'll try and put a card back here so you can see there is a slight color difference here as well. So again, with the nutrient solution that we have, it is almost entirely, oh, this is the wrong card. It is almost entirely, it's over 10 parts per million. We don't really know because we're at the top end of the spectrum there. We are off the charts, as they say. Whereas in the compost, whereas in our compost, we're at about somewhere in between 2 and 5 parts per million. And again, that is just phosphorus that is leached out of a compost that was made water soluble by vermicastings, by earthworms. And so that's really what most of my research is looking at, are the microbial mineralization of plant essential nutrients, specifically the function from ammonia to nitrate and the conversion of phosphate. And so one thing that I'm looking for here is if these levels are compatible with commercials, or if they're incompatible or comparable. Mainly because I want to see if it would be possible to basically run a hydroponic operation off of dirt in a media bag. Basically putting composts into a reservoir as your nutrient solution, as opposed to continually purchasing nutrient supplies or salts and then having that just leach out the back of a greenhouse. Well guys, that I believe concludes our titration. I had a lot of fun doing it. I hope you guys learned quite a bit. Again, this is something very easy, something you could do at your own backyard. You can test your own compost tea, you can test your own nutrient solutions. They're a really fun little kit, and they're pretty easy to interpret. They don't have a super wide range of numbers on them, so you may get off the chart sometimes, but that is just kind of a part of being a soil scientist and dealing with nutrient analysis. It is very, very difficult, and guaranteed analysis is quite an amazing thing that we have for nutrient fertilizers, and it's my personal goal. I would like to see that technology, or at least that bureaucracy, I guess you could say, that amount of regulation on composts and all soil amendments, so you know exactly what you're adding and any type of reactions it may have, good or bad. Because educating people on how to rebuild the soil, I think, will be one of the most important things in the coming future. And I made you one other video today over another topic. I'm not really sure if I'm going to have enough time because I do have a lot of writing to do, so we'll see if I get around to it. And as always, governments may rule the world, but forums are where it's changed. So get online, do some reading, do some research, become a citizen scientist, and, you know, be the change you want to see in the world. Thanks, guys.